In the last example, we looked at a graph of a rational function to identify the domain and asymptotes, amongst other things. Now we want to look at how we can do that just by investigating a given rational function itself. So in example 2, we have the rational function negative 3x squared over the quantity x minus 9 times the quantity x plus 5. To find the domain, we essentially need to find any restricted values, which means any points where the denominator would be equal to 0. Or more precisely, we can't have the denominator equal to 0. Setting each of those factors equal to 0 would tell us that x can't be equal to positive 9 or negative 5, which means that our domain in this case would be negative infinity to negative 5, union negative 5 to 9, union 9 to infinity. Where again, essentially what we have is an interval from negative infinity to infinity, and we're creating breaks at each of those x values where our function is undefined. In example 3, we need to start off by factoring the denominator. In this case, that would factor as 5x plus 1 times x minus 6. But then the same idea applies. We can't have that set equal to 0, so we would get restricted values of negative 1/5 and positive 6. Meaning the domain for this function would be negative infinity to negative 1/5, union negative 1/5 to positive 6, and then union 6 to infinity. In example 4, we take the same idea one more time, take our denominator, set equal to 0, or more specifically find values, we need to restrict that from ever being equal to 0. Subtracting 5 to the other side would give us x is equal to negative 5, but we can't have any real number squared equal to a negative result, so that can never happen, so we have no restricted values, which means in this case, the domain for this function would be represented by the interval from negative infinity to infinity, or by simply stating that the domain is all real numbers.